I'm Phill Conrad, and I'm a teaching professor at UC Santa Barbara, and I've been working with Chris Sundhausen on this NSF grant, this NSF project, to investigate brownfield pedagogy, the idea that in a project-based software engineering course, students would, rather than starting a project from scratch, inherit a code base that has already been worked on by previous students, add their own contributions to it, and then that code base is passed on to a future group of students. As part of this project, we've had to try to build some tools to deal with the logistical issues of running a project-based software engineering course, the issues involved in assessing a software engineering course, and the issues around doing research about the effectiveness of different techniques that you might use in a software engineering course. And in each case, having this tool has been really helpful for us. The tool is still at really in an early stage. The tool started as a project that really just had one job, and that one job was to make it easier to get students into the GitHub organization in the first place. If you want to set up a GitHub organization for your course, this has a lot of benefits. You can set it up so that the instructor and the teaching assistant, if you have one, or teaching assistants, can see all of the repositories for all of the students in the course. But students can either only see you can set it up so that students can only see their own repository, or multiple students can share a repository either as a pair or as a team. You could set it up so that the repositories can be seen by other students in the course, but not by students, not by members of the public outside the organization. So there's a lot of flexibility in using a GitHub organization to organize the code base for a project-based software engineering course. But you've got to get the student into the organization in the first place. There is a tool from GitHub called GitHub Classroom that allows you to do that. But one of the frustrations that I experienced with GitHub Classroom when I first tried to use it about 5 years ago was that at the time, there was no way to upload a course roster and have a matching between the GitHub ID and the student ID. So you would set up your GitHub Classroom, provide students a link, they would join the GitHub Classroom, and then at the end of the day, you had first student, GitHub ID C. Smith. Oh, that must be Chris Smith. That's easy. Next GitHub ID, Skater Girl 27. Who is that? Surfer Dude 32. Beats me. How do you even know if these people are even in your class? The URL that you give out allows anyone that has the URL the ability to join the class. So we wanted something that was a bit more that would really give us a good control, first of all, over who could join the GitHub organization. We wanted only people who were on the course roster to be able to join the organization. And we wanted a very clear mapping between the GitHub ID on the one hand and the student email or student ID on the other hand, so that we could be sure that everyone in this GitHub organization was a registered student of the class, and for each registered student in the class, we wanted to be able to find out what their GitHub ID was. So that's where the tool started. So now I'm going to show you the tool, and I'm going to show you the student view of the tool first. If you would like a student to join a GitHub organization for your class, you first set that up in GitHub. And we have another video that you can watch later if you like, if you want to know all the details of what that looks like. So we can provide you the link to that. But right now, I'm just going to show you what it looks like for a student. So I'm going to click Sign in with GitHub. And I'm actually going to use my spouse's GitHub ID. I use my spouse's GitHub ID all the time for these demos so that I don't violate FERPA. So I'll put in the password. My spouse doesn't actually use GitHub, so this is really my account. I will click sign in, and it's going to ask me for the two-factor authentication. And so I will put that in. And now we have logged in with our GitHub account to this tool. And in this case, I have added my spouse to the course roster of this course, Allolib S22, that I'm teaching. And so if my spouse were a student in this course, they would click join, and they would see, you were invited to Allolib S22, view and accept your invitation here. And we can see that my spouse was already a member of this test course, as well as now Allolib S22. Click to accept the invitation, click join, and now the student is in part of the organization, and it's that simple for the student. So far, that is the only student-facing functionality that we've built into the tool. But as we'll mention, we have lots of ideas for other things that could be built into the tool for the student. Okay, so I've come to the page for one of my courses, and I've made the window for the browser small enough so that you cannot see any of the data. If I were to bring this page down, you would actually see the student ID, first name, last name, email, whether or not they are enrolled in the course, their section, whether or not they're a TA. We also have an integration with Slack, which I'll talk about, their GitHub ID, their organization status, that is whether or not they have joined the organization yet or not, what team they're on, if they're a member of a team, and this is something that we do for the research part of our tool. After the course is over, we get from a separate member of the research team data about whether the students have given informed consent or not to participate in the research. And then we can select out data only for students that have given informed consent. So that's what this field is for. During the course, while the course is in progress, we don't have this field populated because, of course, it's not legit to know whether a student has given informed consent or not while you're still responsible for giving that student a grade. So we only populate this field once the course is over. So I want to show you now some of the convenience features. One of the things that's really handy is the ability to make a GitHub repository, set up a GitHub repository for every single student in the class, matching some naming convention. So for example, if you have programming assignment 1, you can go to repos and create assignment repos. And you can put in here the assignment name, for example, programming assignment 01. And then you can select whether you want the student to have read-only permission to that repo, write permission, or admin. And you can select whether you want the repo to be public or private. So for example, if we say admin and private and PA01, and I click create repositories, then it will go and create a repository for every student in the course. And if their GitHub ID is like C Smith, it'll be PA01-C Smith. If it's J Jones, it'll be PA01-J Jones. And so very easily the repositories are immediately set up, and the instructor and the instructional staff, so the instructor and TAs, if there be any TAs, have full access to all these repos. But if you set it up as private, the student can see only their own repo. So this is a really handy way to quickly create those repos. And of course, students can create their own repos if you set up your organization that way. However, doing it this way ensures that every repo follows a predictable naming convention. And if you're grading programming assignments at scale, being able to have that predictable name is super handy. But we go a step further. If you set up teams in your GitHub organization, then you can also create assignment repos based on teams. So if you want to use all teams in your organization, you can use a regular expression. Now this is a little, I think, something that we want to kind of improve upon. Right now this is a little bit, I don't know, wonky in the sense that it's dot star. You have to actually use a legitimate regular expression if you want everything. But then you can come down here and whatever the name of the team is, so for example, you see here are some of the things I've used in the past. Team01-team will create repositories, team01- and then the team name. So if your teams are, apple, cherry, banana, there'll be team01-apple, team01-cherry, team01-banana. And you can set the team permission to that repository as either read, write, or admin, and you can set the repo visibility as public or private. And it will automatically set up all the repos for all the teams and give each team the correct permission on GitHub. So it's super handy to be able to do this with just one click. In my course, I typically have at least 4 team assignments, and it's just so nice to be able to just set up these repos and then, one click and you're done. So those are a couple of the convenience features. What I want to pivot to now is some of the analysis features. So first, let me go to this, this menu where we have project repos. And you can designate some of the repos in your organization as project repos, ones that are being worked on by teams as a team project. And so in my course, there are 12 teams, and there are 6 of these project repos. I've set it up so that we can get a comma-separated value file of all of the commits, all of the issues, and all of the pull requests. So this has been extraordinarily valuable for our research. We wrote a SIGSI paper looking at how to evaluate commit and issue quality, and it was these CSV files that were the source of our data. All right, so I'm going to show you that if I click on CSV, it downloads a file, CSV file of the commits for this repo. And what I'm going to do in a moment is I'm going to open that up in Google Spreadsheets. So bear with me a second while I pause the video for a second. Okay, I've opened up the CSV file that we downloaded from our tool in Google Sheets, and I've redacted the columns that have private information like names and emails and GitHub IDs. But what you can see is that for each of the commits, we have the commit hash. We have what team the student is on, and let me go ahead and do format wrapping clip, so that's a little bit easier. You'll see that some of the commits don't have a team associated with them. These are typically commits that were done either by students from a previous quarter. Remember that we are doing brownfield projects where this GitHub repo was worked on by students in a previous instance of the course, inherited by the teams in this course who then contribute their code. So commits that were done by previous students or by the instructor or by course staff like teaching assistants, those don't have a team. So you can pull those out. We have a column here for author consent. It's not populated since I mentioned this is data from a course that's still in progress. We have just about another week left before our term ends. We have the URL of the commit on GitHub. We have the commit message, and this is where this has been really handy for our research and going through and looking at how well students write commit messages. One of the things that I would like to do, and is kind of on the roadmap for next year, is to be able to use this to actually give both formative and summative assessment on commit messages. What I would like to do, for example, is be able to pull out a random sample of a student's commit messages and then give them a grade early in the quarter, maybe a low stakes grade, where we say, these are good, these could be improved. And then do that a few times during the quarter and hopefully see some improvement in the quality of their commit messages, and then at the end give them a summative grade where we take a random sample of their commit messages from the last 2 or 3 weeks of the course, hopefully by then they have internalized how to write a good commit message. So you can see some of these are not bad. Add get section JSON function and curriculum service. I think that's a pretty decent commit message. Some of these others, updated link description, maybe not quite as good, but these are not bad. So you can also see that for each of these commit messages, we have a bunch of other information as well. One of the things we get is the number of files changed and the number of lines added or deleted. And we actually did another paper where we replicated a study by Kevin Bufferty from Cal State Chico, where he looked at relative line share and relative commit share of different members of a team. And we used this data to follow up on that research. One of the things we did was to look at, there are certain kinds of commits depending on what framework you're using. For example, if you're using Node, the JavaScript framework, there is a file called packagelock.json that is actually an object file. It's not a source file, but whenever you make a change to package.json, it results in many lines of code appearing to be changed in package.lock.json. And that those changes can dwarf the actual number of lines of real source code changed by the student. So those need to be excluded from the count in order for the line share to be a valid metric. So one of the things we have over here is the adjusted counts of the lines. We can see that there are some that that meet our exclusion criteria. So there's a lot of there's a lot baked into the tool in terms of being able to do proper research on GitHub commits, GitHub issues, GitHub pull requests, and so forth. So that's a little bit of a look at the CSV download feature. And as I said, we have downloads for commits, for issues, and for pull requests. You can get this data from GitHub, but it may not be annotated with the actual names and emails and student IDs of your students. So if you want to use that data for assigning grades or for feedback, I think this is a really handy tool to have. So let me stop the video for a moment and get ready to show you a few of the visualizations that we've started to build. Okay, we're back here in the tool, and what you're seeing now is the repositories, and for each of those, the commit count, issue count, PR count. If I look only at project repositories, you can see these are the ones that really kind of matter, the culminating project for the course. And the other thing I want to show you is that if we go to this GitHub Teams tab, here you can select any of the teams in the course. I'm only going to select 6PM4 because in order to respect FERPA, one of the things I've done is replace the students' names with initials. These GitHub IDs, don't look them up. So if we come down here, you can see that the 6 students on this team have had very different levels of, in terms of the number of commits that they have contributed. By the way, we only look at, in this, we only look at commits that have actually been merged into the default branch. So the default branch, by that, in the past, it was called master. It's now called main, typically. And the way that I run my course is you have to get a pull request code reviewed by a peer team member and then by a member of the course staff. And it gets, once it is approved and merged into the main branch, that's when it counts. That's basically how you earn points towards the project. So those are the commits that count in this visualization, and we can see that this student has contributed almost twice as many commits as the next student, and then there's one student who has not yet contributed any commits at all. However, there are quite a number of pull requests that still have to be merged. So it is possible that this student's contributions are still just waiting in the pull request queue, and that by next Monday, this student's bar will be much higher. Now, so far, this is still a feature in development. We have not yet used this feature for formative assessment, and so far this is only visible to instructors. But one of the things we would like to do is think about making a feature like this available to the students so that they can look at it during their Agile retrospectives and think about what it means. It's important to understand that just because someone has twice as many commits as someone else doesn't necessarily mean that they have been twice as productive. It could be that some people are in the habit of doing lots and lots of small commits, whereas other people are in the habit of doing much larger, less frequent commits. And both of those at the extreme might be considered not good practices. There's probably some middle ground that is the right, good practice in terms of how many commits you should make and how often you should make commits. So it's important not to read too much into a graph like this, but it does tell us something, and it's something useful that students could reflect on in their retrospectives. Clearly, though, if someone has no commits at all, that's possibly a sign that they've been doing pair programming together with another student. It is possible to put more than one name on a commit. So if this kind of a visualization is going to be used to assess individual contribution, maybe that's something that students would need to do. But in any case, these are some of the things that we're thinking about, and some of the things where your input could be really valuable. A second graph here is the lines of code changed. And again, you can see that there's big disparities on this team. But does that mean that this person did, 20 times as much work as this person? Not necessarily. Perhaps a very small number of lines of code required a great deal of research, and maybe all of these lines of code were fairly straightforward to write. So any metrics in software engineering in terms of contribution can be deceiving if looked at in isolation. So we have to be a little bit careful about these metrics and these visualizations. Nevertheless, they do provide us with something interesting to discuss. This is where I'll stop. I have a couple of other videos about features I would like to see built into the dashboard in the future, and I'll leave it up to Chris whether to share those with you separately or not. But in any case, thank you for watching, and I look forward to hearing your thoughts about what we've built, whether it might be useful, and what other features you might like to see in a tool like this. So thanks very much. Once again, I'm Phill Conrad from UC Santa Barbara. Now back to Chris Hundhausen live in Washington, D.C.